All right, this is a solution for the problem-solving question. Okay, so we're going to split our solution up into two parts, part A and part B. And first thing I'm actually going to do is I'm going to make use of a proper diagram. Okay, so a cylinder is requested to be made so that the cylinder is 4 times as long as its diameter. And we're told that our cylinder has a radius of r. So time for me to get my information sorted. If my radius is r, my diameter, which is always going to be twice my radius, is going to be 2r. If my diameter is 2r, that means my length, which needs to be 4 times as long as its diameter, is going to be 8r. Okay, 4 lots of 2r. So once I've got those things together, I can now start to put together the things in my formula. So the volume of a cylinder, I'm going to put VCyl for volume of the cylinder. We take the area of our cross-section, which is pi times our radius squared, and then times it by its length. Pi is just a number, so that isn't going to change. Our radius is r squared, and our length is 8r. Index laws. Standard index law here, nothing particularly mental. I've got r squared times 8r. Now, this would be the same as us saying 1r squared times 8r. Our pi hasn't really done anything to this. It's just still kicking around, having a good time. We've got 1 times 8, which is 8. And then r squared times by r. And if you remember what happens to your bases when you multiply... Oh, sorry. What happens to your powers when you multiply the same base? Our powers get added together. So that's going to be r cubed. So our expression in terms of r is going to be 8 pi r cubed. Not too bad. Part B, though, will require a little bit more of a look in. Our surface area for our cylinder is going to involve 2 lots of the top, because the top and the bottom are the same area. I'm just going to say 2 lots of our top. And then add on our curved surface. Now, if you imagine taking like a piece of paper that's been rolled up to create a cylinder, and you unroll it, you're going to have a rectangle. Okay? Where this bit, if you imagine your piece of paper that you've rolled up, that is going to be your length. And this bit, the bit that forms the circular part at the top, that is our circumference. So this thing, the curved surface area, is going to be circumference times by length. Now, if you remember as well from your circle song, if you need circumference, you should use pi d. But that means we've got everything that we could need. We've just got to kind of put it all together. So, the area for the top, pi r squared. Radius, that's fine. Our curved surface, right, so our circumference is pi times our diameter, which is 2r, and then times by the length, which is 8r. Let's see what we can simplify here. So we've got 2 pi r squared plus 2 times 8, which is 16, pi r times r, which is r squared. Now, if you remember our examples for our standard index laws, we said that if we were multiplying or dividing, our powers get affected. But if we're adding or subtracting, our powers have to be the same for us to do an addition or subtraction. And that is exactly what we've got here. We've got the same power and the same letter. So if I have 2 pi r squared and I add 16 pi r squared, overall I'm going to have 18 pi r squared. Okay, and there is my expression for the surface area of the cylinder in terms of r. Okay, it's the standard index laws that we would see in a crossover selection of questions, but this question is very much, one of those higher order questions because it involves you knowing formulas, knowing how to apply it in terms of algebra, and also then possibly doing something with it. Okay? I'm going to leave it there. Enjoy your half term.